So in this tutorial we're going to be talking about how to factorize cubics, and more specifically we're going to talk about how to factorize a cubic when we know one linear factor. So we've already worked out what one of the linear factors is, and we're going to divide that linear factor into the polynomial in order to get the other quadratic factor that would remain. And the first method to factorize is by inspection. And so if you divide this polynomial by the linear factor x minus 3, then the result has to be a quadratic. And because if you were to multiply a quadratic with a linear factor, you would get a cubic polynomial. So we can actually write the quadratic as ax squared plus bx plus c. And because we know that the cubic must equal the linear factor multiplied by the quadratic factor, therefore we can ascertain a few other things as well. So imagine multiplying out the brackets where we have x and ax squared. Now when we do multiply them out, we'll always end up with the cubic factor here. X multiplied by ax squared has to equal this cubic factor here, and therefore because x has a coefficient of 1 and our answer has a coefficient of 1, then 1 times by what number gives 1? Well, 1 times by 1 gives 1. So a must equal 1. At the same time, we can actually say that if we multiply -3 by c, we have to get a constant of -6. And so therefore we can actually say that -3 times by 2 equals -6, and therefore c must be 2. So now let's think about the x squared term here. So we've got -x squared here. We've got -1 as the coefficient of the quadratic variable over the left hand side. And when we multiply out these two sets of brackets here, we will end up with two quadratic variables. So the first one is the first one is -3x squared, multiplying out -3 with x squared. So the first one would be -3x squared. The second one would be x multiplied by bx, which is bx squared. So we've got -3x squared and bx squared, and they have to equal -x squared. So what we can actually do is we can turn it into an equation. So we have our -3x squared plus our bx squared, which equals our quadratic variable on the left hand side. And if we add -3x squared with some number, it must equal -1x squared. Well, the answer to that is 2, obviously. So -3 plus 2 gives -1. Now we can work out, we can actually check to make sure this is true by calculating out the linear variables. And you can see here that we've got x multiplied by 2 gives us 2x, -3 multiplied by 2x gives us -6x, and when we add 2x and -6x together we should get -4x, and we can write that as an equation as well. And so so that is true, therefore our quadratic factor should be true as well. Now at this point, once you've worked out what the quadratic factor is, you can actually then go and use your quadratic factoring skills to factor the quadratic. It just so happens that this quadratic factor only has one real solution and a couple of complex solutions, but we won't actually cover anything to do with complex numbers in this course. So there's another way we can factorise a cubic, and some might even consider it to be easier than the first method, and that is factoring using a table. And think about this for a moment. So if we have a table, and it looks a little bit like a Punnett square from year 10 biology, but basically when we multiply this table out and we add bring in the cubic, we add the two quadratic variables, add the two linear variables, and bring in the constant, we end up with a certain polynomial. And what we can say is that this linear factor and this quadratic factor must multiply out to make our polynomial. We've got our 2x squared here, we've got our 3x squared, negative 3x squared, beautiful, negative 9x, negative 8x gives the negative 17x, and we've got our negative 12, which is here. And so just, if you're thinking about that for a moment, then what we actually do to actually get our quadratic factor, because that's what we're going to be after, is we'll be given a cubic polynomial, we'll be given one of the linear factors, and we'll be asked to find what the quadratic factor is. And so we actually go in reverse to do this. And so if you divide x cubed minus x squared minus 4x minus 6 by the linear factor x minus 3, then the result must be a quadratic, and we can write that in a table. And so the result of multiplying out this table has to be this cubic here. And therefore, when we multiply out x by ax squared, which would give us a cubic variable, it has to be x cubed. So therefore, what coefficient of this quadratic variable must multiply with x to give x cubed? Well, if this coefficient's 1 and the answer's 1, then this has to be 1 as well, the coefficient of this quadratic variable here. Likewise, we can find out what the value of c is. And that's because if we have a constant of negative 6 in this position here, then we know that negative 3 must multiply with some number to give negative 6, which obviously we worked out before to be 2. 2 times negative 3 gives negative 6. Now there's two more spaces in the table that can be filled in, and that's the negative 3 times by x squared, which gives negative 3x squared, and the 2 times by x, which gives 2x. And so now we want to fill in this space here. And so this space here basically is where we're trying to put in a number here, a quadratic variable here that adds with negative 3x squared to give negative x squared. Well, negative 3x squared plus 2x squared gives negative x squared, and therefore 2x squared must go in this position here. And so this shows that b must be 2, and this shows that b must be 2, and that's because bx times by x gives 2x squared, therefore that's 1, and that must be 2 to give 2 here. Now with the last space in the table, this last space basically is where we add some number with 2x to give negative 4x. So some number plus 2x gives negative 4x. Negative 6x plus 2x gives negative 4x, and therefore that space must be negative 6x. Then once we've done all that, then we can actually say, well, the quadratic factor is x squared plus 2x plus 2. And the last method that we can actually factorize a cubic with is through algebraic long division. And I've already talked a little bit about this in class, but I'll go through it again right now. So we're going to divide a linear factor of x minus 3 into our cubic here. And at this point I just want to point out that there are three parts to long division. There's the dividend, which is what goes underneath the division sign, and it also represents the cubic. We also have our divisor, which is our linear factor, and when we compute that out, we end up with our quotient, which is our quadratic factor. So first we divide the dividend of x cubed by the x in the divisor. And the way we do that is we multiply x in the divisor to give a value of x cubed. So what number multiplies with x to give x cubed? Oh, that's x squared. So we put x squared on top of the line, and then we multiply the linear factor by x squared, and we write that answer underneath the first part. So you can actually see here we have our x. So x squared multiplied by x minus 3 gives x cubed minus 3x squared. And what we have to do is we basically put this in a set of brackets and then minus these terms with the terms above them. So x cubed minus x cubed will always equal 0, and negative x squared minus negative 3x squared, and this trips up a lot of people. When you're subtracting a negative sign, you're actually adding. So negative x squared plus 3x squared gives 2x squared. And then we bring down the next term because we're going to be dividing by both terms with our linear factor. So now we look at our linear factor of x minus 3, and we need to say, right, what number do I multiply x with to give us 2x squared? Oh, that would be 2x. So I write 2x on top of the line. Then I multiply my linear factor by 2x, and that gives me 2x squared minus 6x. And so then I subtract this answer here from the 2x squared minus 4x. And so that would give me, so 2x squared always gives me 0. Negative 4x minus negative 6x is actually plus 6x. So it ends up being negative 4x plus 6x gives me 2x. And then I bring down the final term of minus 6, and I divide my linear factor into that. Now with this I only need to multiply x by 2 to give 2x. So I put 2 up the top, and I then multiply the linear factor by 2 to give me what I need to subtract from my 2x minus 6. So it just so happens that when I multiply this linear factor by 2, I end up with 2x minus 6, and so that means that there is no remainder. If I end up with 0 at the very end, it means there is no remainder, and so that means that my quadratic factor multiplied by my linear factor must exactly multiply out to give my dividend, which is the cubic.